On your mark, get set. Same thing. How do I give kids a reason to care? Ready, set, tell the person sitting next to you 5 things you notice. Good morning, boys and girls. Y equal 3x squared minus 5x plus 7. There it is. You know the problem is vocabulary. You know the problem is the kids have no idea what's going on here. Look at the power of, turn and tell your partner 5 things you see on Mr. L's board. Look at what happens when the class sits there in their groups and then spits out. I see a polynomial, I see a trinomial, I see a quadratic, I see a second-degree equation, I see variables, I see exponents, I see coefficients, I see a function, I see a u that opens upwards, I see a minimum, I see 2 roots. What? That is helping kids make sense of this slew of vocabulary that is so critical if they're going to be able to handle the test and they know what those words are. And so I don't care what I do, this pause, turn and tell your partner what you see. Kids tell me, I see a gauge. I go, a gauge? G-A-G-E? Kids go, yeah, a gauge. I think it's G-A-U-G-E. We're not gouging, we're gauging. Oh, cool. I know it's hard, but we're doing language arts because you always do language arts, right? And so it's gauge, gouge. Wait, what's the gauge? What's the gauge tell you? Your gas tank ain't full. How much? And then I got the manual. Look what I've done. I got kids that can't read, so I give them a reading list problem. On your mark, get set, right? So I saw the gas, the mileage, the decimals, I see fractions, I see a manual, I see a road sign. Will I make it?
Yes.
Yes, good. Will I make it? No. What does that mean, will I make it? Do I have enough gas to make it 244 miles given that data? Ready? Yes, I'll make it. No, I won't. Top and turn and see if you agree at the table. No. Look at all I'm doing. I'm saying to you that 3 of the 8 are tasks, questions, and discourse. The 3 of the 8, the important ones, okay? Yeah, this fits into my goals, that's cool, but a task that kids would care about. Well, real data, information, question, will I make it? Discourse, convince me. Who wants to stand up and say, I won't make it because, or I will make it because? Thank you, ma'am. Loudly, please.
You will not make it. Because, according to the data we're given, at 28.3 miles per gallon at 21 gallons, I did a 4th just to be safe because I know the bottom half of my gauge goes faster than the top half of my gauge. Okay? You will make 148 miles.
Look at that. Where'd the 148 come from, please?
28.3 times 21 divided by 4.
Look at that. In other words, that person's smart enough to sit there and multiply the number of gallons in the tank times the number of miles per gallon, get about 600, and divide that by 4, because in fact you know that it's a little more than a 4th, but it's probably a 4th, and you want to play it safe. And plus, most of you know that you're going to fill the tank with gas when it's at a 1/4 of a tank anyway, so that you're not stuck on I-70. So you have to find a way to make sense of this. How nice. And therefore, when I divide that by 4, I get 148.90 to go 200 and hoozy. Who did it differently? How'd you do it, John?
I Googled it, and it's only 143 miles from here, so I knew that a 1/4 tank of gas would get you there.
Isn't that awesome? You see, I told John to make it, right? He Googled it, all right? Except for one small problem. I never said you were here. Oh. You see, that's a real sign. But I'm over there on the Colorado border. Oh, cool but nice. I like your thinking. I'll make it because, I won't make it because. Who did the whole 600 and then divide it? Like the lady in purple did. Good, who did it differently? What'd you do?
I said suppose it was half full. I said suppose it was half full. Half full, this car can go approximately 500 miles. I know very few cars that go 500 miles on a tank of gas. And it's significantly less than half, so therefore I can't make it.
Whoa. And we can go back and have him explain some of that, because I think you know that he had some small errors in his thinking, but that's okay. I don't think it meant half the tank, but close, and how and what, and it would. Good. Another way. Look at the discourse, sir.
I estimated that at about a third.
There you go. This a half. Come on, it's a third, right? There's probably a little extra in the tank. Good. So a third.
So 7 gallons. Rounded
7
up-
gallons, a third of the tank. So that's 7 gallons at 28 miles a gallon.
I rounded up to 30 and said I could do that.
210. So maybe you make it home on fumes, but what's the story? You don't have any money. You're a teenager. Oh. Are you going to make it? Are you not? Hey, gang, what do you do when Robbie, you know who Robbie is? Robbie is Kyle's cousin. Those are the two kids that could drive us crazy. You are looking already at your class list, hoping that you have neither Robbie nor Kyle in any of your classes this year, right? And Robbie goes, Mr. L, I don't agree. Robbie says, well, you got about a third of the tank, so that's 7 gallons, but everybody knows gas companies leave 2 gallons in the tank when it's on empty. You all know that it reads empty, but you can still go a bunch of miles. That's what happens when you press those buttons. So in fact, I got 9 gallons in the tank. If I'm in Nebraska and I'm on I-80, then everybody knows that, or I-70, whatever the heck it is, that everybody knows that you got highway mileage. The 28.3 is an average of 25 and 35. At 35 miles a gallon, going carefully at 65 miles an hour on 9 gallons, I'm going to make it home and let my brother go fill the tank up tomorrow morning. Who's right? That's right. Like assumptions. That's what I call empowering. That's what I call the discourse that emerges from the right questions. Right? You're not convinced about how I get, how far. Now go mark the tank gauge with where you would be happiest to know you'd be able to make it. How many of you are so risk averse that it has to be full before you'd even take the car out? How many of you are going to try it at a half? Of course, it's great. And now we start talking about moving from mathematics to the real world. Okay, wonderful. Your turn. Turn and talk. What made that effective? What made that effective? Why is it that you should be sitting and saying, oh, I need to find more problems like that. I need to start my classes with that. I need to build them in. Why? You know why I didn't give up on you. Ladies and gentlemen, you may not know this, but 1 hour equals 1 month. 1 hour in this room is the equivalent of 1 month with your kids. The fact of the matter is, if you try this in September, your kids are going to sit there and go, what the heck? That's the way that's supposed to be. That's not the way it was last year. And they'll be just like you were for the first half an hour, where I couldn't get you to talk, I couldn't get you to care, I couldn't get you engaged, and look at what happened. We're now 1 hour and 10 minutes in, and all of a sudden, I ask you what made this effective, and the room begins to loosen up. That's what it'll take. Your kids will not participate until November. They will not start caring unless they had someone doing it last year. That's why we're so interdependent. That's why this can't be just something that, well, I'll try. This has got to be the way we teach math. This has got to be why. I'll wait. Why I have something in the handout for you, okay? So, we could have a discussion now. I'm going to save the discussion because I think that so much has already been taken care of at the table. I know that you're saying, right, oh, there were words. Oh, you asked the right questions. Oh, it gave kids a chance to talk. Oh, it was an intriguing situation. How can you go back and just say, let's go factor this equation, right? When I have to have a reason to do it. And so, one more, gang. Right? So this is Sarah and her apples. Once again, our questions are discourse representations, turning lemons into lemonade. Good morning, my bright-eyed, bushy-tailed 6th graders. Who teaches 6th grade? I honor you. Every one of you in this room who thinks that you are successful needs to kiss the floor upon which a 6th grade teacher walks. You can laugh all you want, gang, but for most of our professional careers, 4th grade was the killer curriculum. It is no longer. 6th grade is the killer curriculum. 6th grade is where the very best teachers in the world have got to teach. Sixth grade is where, if we follow our standards, and if we understand just how critical it is, 1/4 of the year is basically problem solving involving addition, subtraction, multiplication, and division of whole numbers, fractions, and decimals. Oh my goodness. Sixth grade, the whole first quarter of the year is menus and price lists and problems involving buying and selling and comparing. And do I add, do I subtract, do I multiply, do I divide? The only thing that is new in all of sixth grade is division of fraction by fraction. And yet everyone who teaches sixth grade knows that kids are still very weak on their decimals. They don't understand decimals of fractions. They are confusing rules still. They can't divide fractions because they don't remember that rule, and the rule never made any sense in the first place. As if that isn't a monster bite for the first quarter of the year. Oh, guess what, you bright-eyed sixth grade kids? We are now going to do a quarter of the year, not a chapter. A quarter of the year on ratios, rates, and proportions. Most of you know that this is the single most conceptually trying concepts to learn and to teach. There is nothing in calculus, there is nothing in high school algebra that is as hard as this idea of a rate, of a ratio. And then, and it's all brand new. And then I have a quarter of the year on the first time they're ever really doing algebra. And they're doing equations and expressions. And if those 3 quarters take the whole year, I'm happy, because the only thing that gets is some geometry and statistics, and they're nowhere near as important as all of this. Hey gang, you don't think this is absolutely overwhelming? You want to see why your lives in 7th grade and in 8th grade and in 10th grade are such nightmares? You want to see why similarity is such a nightmare when we try and do it in geometry? It's because when 6th grade is done poorly, I have worm A. Worm A grew from 3 centimeters to 7 centimeters. Wow. I have worm B. Worm B grew from 4 centimeters to 8 centimeters. We together? Turn and tell your partner which worm grew the most. Goes from 3 to 7, the other goes from 4 to 8. Well, yeah, and there it is. Why is 6th grade so hard? Because in the beginning of 6th grade, every kid says they grew the same. This one grew 4 centimeters, this one grew 4 centimeters, don't bother me. How did you get 4? I subtracted. Oh, cool. And you know that's where they are. If kids do not leave 6th grade understanding that additively they grew the same, but this one doubled in size, this one went up by 2 1/3, it more than doubled in size. How did you get the 2? I divided 8 by 4. How did you get the 2 1/3? I divided 7 by 3. Oh my goodness. And if you don't in your gut, in your belly, understand what a gigantic conceptual leap that is, if you don't understand how hard it is to then talk about representations, we're sitting there talking about how the standards that you have say a double number line. It says a tape diagram. It says use a representation to make sense of this, to see what we are meaning by multiplicative change as opposed to additive change, indispensable. And then, as if you think that that's so easy, come on gang, 6/10 plus 6/10. You ready? Answer? 12/10. What else could it possibly be? That's what I taught you in 4th grade and in 5th grade. And that's exactly what we just did in solving all those problems at the beginning of 6th grade. And then all of a sudden, we just dropped the bomb on kids' heads and say, well, yeah, that's fine so long as they're fractions. So long as that 6/10 lives on a number line. So long as that 6/10 is a number. Because you know what happened last night? Kevin Durant hit 6 of his first 10 shots. He hit 6 of his second 10 shots. Kevin Durant hits 12 of his first 20 shots. Whoa, what did you just do, man? I added the numerators. I thought you couldn't do that. I added the denominators. I thought you couldn't do that. Well, in the world of ratios, all of a sudden I can do that. Go ahead, you look at me and tell me that's easy. You go and tell me that a mediocre teacher can help kids understand that. And I will tell you that there's 6th grade and what's so critical. And so how do I make that all work? Take a deep breath, guys. I'll tell you how you don't do it. Good morning, my bright-eyed, bushy-tailed 6th graders, launching secondary mathematics. Building the platform that will allow you to be successful in calculus in another few years, to have an understanding of statistics, and we do it. Sarah has 91 empty boxes. She has 2,700 apples to pack into the boxes. How many apples will Sarah put in each box? Go. You all know, 1/3 of your kids sit there and go, oh, you have to buy 2,700 divided by 91, get an answer, and then here's we're done. And there it is. Mathematics as getting answers without any understanding. Versus, are you ready? Gang, take a deep breath, and then we'll take a break. Ready? Adapting. Turning lemons into lemonade, adapting what we know. What is it that's good instruction? What do we mean by those 8 mathematical teaching practices? What we mean by that is giving kids a reason to care and supporting their learning. Boys and girls, read with me. Sarah. Wonderful. Would you please tell me what you can infer about Sarah? There it is. I mean, you have to love that. It just took me until the end of November to get you guys loosened up. To have a question where immediately the room erupts because someone is saying, I can infer that she's crazy. She's moving, right? She's a hoarder, right? You say that? Kids tell me she's already packed 9 boxes. I go, how do you know that? Kids go, well, you're not going to order 91 boxes. She ordered 100 and she packed 9 of them. She's got 91 to go. I've got my brightest kids going, this is not fun. Because they don't think outside the box. I got everyone else saying, this is awesome. Oh, that's so cool. And for the first time in the history of your kids, they give a damn about Sarah and a word problem. Actually, I know something else about Sarah. I take the same utterly ridiculous stuff and I say, oh, Sarah, you know, has 2,605 apples. Now tell me about Sarah. That's right, the kids tell me she's obsessive compulsive as well as being an hoarder. No other human being would count 2,605 apples. She works part-time at her grandparents' orchard, right? Yes, kids last week told me that she was child labor. I mean, what makes you think that? No one else would make her count all those apples and stuff them in the boxes, right? Come on, gang, you know how insulting it is. Every bone in your body sits there and says there ain't no way there's the same number of apples in every box. I mean, if it doesn't say about how many, oh yeah, we go to the strawberry farm, right? Sure, the same number of strawberries in every quart. Give me a break, right? I got big ones, I got little ones, I got all the different sizes, and so the same thing goes with apples. How nice. So now you're laughing and you care, what else can you say? And I come along and say, what do you think the question is? Why? Why would you always ask kids the same question? When it's so much more powerful to say, there's all the data, so? What's the question? Will I make it? How much gas do I need? Wait a second, how big is the glass? Will it fit? All those things. What's the question? Yeah, about how many apples will be in each box. That's really nice. Awesome. Boys and girls, help me with this, right? Now, do I do this for every word problem? No. But you understand that the first time I'm teaching this, the third time I'm teaching this, the way in which I'm helping kids is, so, what good is all the stuff that you've learned in 3rd, 4th, and 5th grade if you can't tell me that the 91 represents? I know the number of boxes, but mathematically? Yeah, it's the number of groups. It's the number of boxes. Oh my God, it's one of the factors. We talk. You know, no sooner do we get done with part, whole, add, subtract, right? Add, whole. We get to factor, product. How many times does a 7th grader say to you, do we multiply or do we divide? Just tell me that, don't make me think. Yeah, you're all laughing because you know how often you hear that. You know, the dumbest thing we can do is tell the kid what to do. Instead, we say, Albert, try it. right? See what's reasonable. Go and estimate first, right? We sit there and say, you think about what's going on. And so what does it tell us? Good. About how much? On your mark, get set. We don't do any near enough estimates. You know, I sat in 50 high school classes, I said, in the last year. I didn't see you ask kids for an estimate on a single algebra word problem in any class anywhere in the world. Those words don't come out of our mouth. On your mark, get set. More than 100, less than 100 apples in each box. Go. More, less, more. Less, more. Oh my goodness. I just made your lives amazingly harder. Either you're sitting there going, oh, that's cool. Of course, if there are 100 in each box, that would be 9,100. So I don't have 9,100, I only have about a quarter of that, so there must be about 25 in each box. If your brain is saying that, then your brain has to say, I need to remember to build those questions into my slides, starting on September 1st. If your brain is sitting there saying, I don't know, and I don't get it, then you have a summer assignment. And that summer assignment is to sit there and worry about why the heck you don't do more estimation in every single math class you teach. Why is it you don't ask kids, here's the data. Good, what's the question? What's a reasonable estimate? That, and that alone with, or that along with why, how do you know, will make all the difference in the world. Good, can you draw a picture? Nice, can you give me an equation? Look what I'm doing for you. I am building in representations, I have got these slides, I teach with these slides. I use this set of progressions of these questions to engage kids, to show you how I have a mechanism to get at the mathematical teaching practices. How every one of you in this room knows there are students that you have and love who sit there and go, why do I have to draw a picture? 2,605 divided by 91, here's my answer. I did it on my calculator, I rounded it, and I don't know how many are left over, but it's close. That's great. They need to draw a picture because before they know it, mathematics is going to require them to visualize it. And then you've got 2/3 of your kids, I don't know what you mean. I can't get an equation. I don't know what operation. When they draw a picture and you see this 2,605 rectangle, and they go 91 little pieces. They go, oh yeah, I'm cut it up into 91 groups. And all of a sudden that picture allows them to say 2,605. You all know that. That's a representation. That is giving kids access to it. I'll tell you what I'm doing now more and more and more and more and more when I coach. I need you to think about, surprise, it's Chuck E. Cheese. Steve walks into your classroom on October 17th of this school year. Oh no, what are you doing here? I sit on the side, I watch for a while, and most of the time, the coaching that I do these days is I sidle up to the board and I just draw a picture of the problem that you're doing over there. High school classes, I walk up to your computer and silently go to Desmos and I put the graphs of what you're doing up on the board. What am I doing? I am simply silently building in another representation. I am coaching by helping you see that we don't have to talk about it. I have to do it, and then I'll tell you what happens all around the world. I did this recently in Shanghai. I did this recently in Guangzhou. I did this with some amazing teachers and some amazingly awful teachers in Zurich. And I do it in Omaha all the time. 1/3 of the teachers go, oh my goodness, that's awesome. Hey, what'd that crazy dude just do on the board? And immediately incorporates it and realizes that it was missing from what they were doing. 1/3 of the time, you just ignore me. That's, you just assume that I'm just this plant that did weird things. And you ignore me because you don't understand what I did. And then 1/3 of the time, it's like, would you want to explain what you did? And I go, no. Why don't you ask the kids? And the kids go, that's a picture of what you're doing. Look at that, he did that. And I go, yeah, would you like to have Desmos on your smartphone? It's free. And all of a sudden, everyone's got Desmos on their smartphone. And we change the rules. Am I making sense to you? Super. Right, why'd you divide, not multiply? Why'd you multiply and not divide? That's the important issue. Can you explain why? And then finally, good. So about how many apples? Right? Look at that progression, gang. Look at how, in fact, in such critical ways, it is our questions that determine the degree to which they learn. It is our questions that precipitate their discourse. It is our questions that have them do representations. It is our questions built around, in this case, the stupidest task you ever saw. And it doesn't make any difference. And now I am building that critical foundation that is so absolutely critical. Ladies and gentlemen, this is awesome.